Look up at the night sky for a moment. It's mostly dark, right? A few little specks of light and a whole lot of black. But here's a fun question. Why? For centuries, this puzzle, known as Olbers Paradox, had scientists completely stumped. It was like a cosmic crime scene where the evidence made no sense. If the universe was infinite and just packed with stars, then no matter where you looked, your line of sight should eventually hit a star. Think of it like this. You're standing in the middle of a forest that goes on forever. No matter which way you turn, your view is eventually blocked by a tree. The night should be a blinding, continuous glow as bright as the sun. But it's not. It's dark. The solution, which we've only recently figured out, is a total mind-bender. It turns out our universe has way more going on than we ever thought. And the crazy part is that the vast majority of it is completely invisible to us. Okay, so for decades, we thought we had the number pretty much pinned down. If you picked up a textbook, it would tell you that our observable universe held somewhere between 100 and 200 billion galaxies. And that number felt huge, like we'd finally mapped out the edges of existence. This wasn't just a guess, it came from one of the most brilliant things we've ever done. In the mid-90s, astronomers pointed the Hubble Space Telescope at a tiny, completely black patch of sky near the Big Dipper. The spot was about the size of a grain of sand held at arm's length. For 10 straight days, Hubble just stared into that darkness, soaking up every last photon. The picture it sent back changed everything. The Hubble Deep Field. Where we thought there was nothing, the image revealed a blizzard of light. Not stars, but thousands and thousands of entire galaxies, all crammed into that one tiny speck. Each one was an island of billions of stars. The logic after that was simple. If this one tiny spot has this many galaxies, how many are in the whole sky? By multiplying that out, they landed on the 100 to 200 billion number. For a generation, that was our map of the universe. But there was a fatal flaw buried in the logic, a flaw that would eventually lead to a revelation 10 times bigger. Here's the problem with the Hubble Deep Field method. It's like trying to take a census of a continent-sized forest by looking at 1 acre from a helicopter, at dusk. You can count the giant, brightly lit trees, but what about all the smaller saplings and shrubs hiding in the shadows? Astronomers knew they could only see galaxies that were bright enough or close enough. They were totally blind to the faintest, most distant ones. This is where the cosmic detective story really begins. A team led by Christopher Consolis at the University of Nottingham decided to go deeper. Instead of just looking at one flat picture, they took 20 years of Hubble data and essentially built a 3D map of the universe through time. It was less like taking a photo and more like building a time machine. They could infer how many galaxies there were at different points in cosmic history. And what they found was astonishing. The early universe was a very different place. When it was young, just a billion years after the Big Bang, it was like a packed party, way more crowded than it is today. A given chunk of space had about 10 times more galaxies in it. Most of them were small, faint, cosmic wallflowers that over billions of years crashed and merged to form the bigger, brighter galaxies we see now, like our own Milky Way. The cosmic forest was once thick with saplings, which have since grown and merged into the giant trees we see today. This new understanding led Consolis' team to a jaw-dropping conclusion in their 2016 study. When they did the math and accounted for all those small, faint galaxies from the early universe that our telescopes had been missing, the total number just exploded. The old estimate of 200 billion wasn't just wrong, it was horrifyingly wrong. Their model suggested that the observable universe doesn't contain 200 billion galaxies. It contains somewhere in the ballpark of 2 trillion. Yes, trillion with a T. Let that sink in. If you tried to count to 2 trillion, one number every second, it would take you over 63,000 years. And here's the most mind-bending part. This new number implies that over 90% of the galaxies that have existed within our observable universe are actually hidden from us. They are ghosts in the machine, too faint, too far, and from too long ago for even Hubble to clearly see. Their existence was inferred from the data, not seen directly. While the exact number is still a hot topic for debate, the new James Webb Space Telescope, with its powerful infrared eyes, is finally starting to spot some of these incredibly ancient, faint galaxies, adding real weight to the idea that the universe was once far more crowded than it looks. So this brings us back to the crime scene, the dark sky. Olbers Paradox was based on the idea of a static, infinite universe. The discovery of a hidden population of trillions of galaxies proves one thing: the darkness is not because of a lack of stars. There are more than enough out there. The real solution is a trifecta of brain-breaking reasons revealed by modern cosmology. First, the universe has a beginning. The Big Bang Theory shows us the universe is about 13.8 billion years old, not eternal. Because light has a speed limit, this creates a cosmic horizon. Light from any galaxy whose journey to us would take longer than 13.8 billion years simply hasn't had time to get here yet. The darkness is a shadow cast by the Big Bang itself. Second, and just as important, the universe is expanding. The fabric of space is stretching, and it stretches the light traveling through it. This is called redshift. It's like the sound of an ambulance siren getting lower pitched as it races away from you. For the most distant galaxies, their light has been stretched so much that it's shifted right out of the visible spectrum and into infrared or microwaves, making them totally invisible to our eyes. The light is still there, but it's a graveyard of light that's been stretched beyond what we can perceive. And third, the big one, the sky is dark because most of the things making light are themselves invisible to us. That sea of 2 trillion galaxies is mostly made of small, faint, ancient things. Their combined glow is just too weak to light up our night, especially when you factor in the first two reasons. The darkness is the shadow cast by 2 trillion hidden galaxies. The journey from 200 billion to an estimated 2 trillion galaxies shows just how fast our picture of the universe is changing. If finding out that we've only been seeing about 10% of the picture blows your mind, make sure to subscribe and hit that bell so you can join us as we keep exploring the universe's biggest secrets. And let me know in the comments, what's a fact about the universe that just completely breaks your brain? So, what does it mean to live in a universe that is 10 times more crowded and 10 times more invisible than we ever knew? On one hand, it's humbling. If you ever felt insignificant before, this doesn't help. It's a reminder that for all our progress, what we see isn't the whole picture. We're living inside a glittering, expanding snow globe of trillions of galaxies, and most of them are playing a cosmic game of hide-and-seek. But on the other hand, it's incredibly inspiring. The solution to that 200-year-old puzzle reveals a universe that is so much more dynamic, crowded, and spectacular than we ever dared to imagine. The darkness of the night sky, the very thing that made the universe feel so empty, is actually a map of cosmic history. It's the evidence of our creation in the Big Bang, the signature of cosmic expansion, and the veil hiding trillions of ghost galaxies waiting in the dark. And honestly, the fact that we, from our tiny little corner, managed to figure this much out, that's maybe the most amazing thing of all. The universe may be vast and hidden, but it's not unknowable. And that makes the darkness feel a little less lonely, and a lot more like an invitation.